All right, let's see if we can go ahead and get lesson 3 in module 4 done today. We left off right in the middle of page 34, which I don't know if those pages match up to the ebook. They probably don't, but if you're trying to follow along, we're in the middle of lesson 3 where we've got the exercises. Exercise 1 says there are 750 students in the 7th grade class and 625 students in the 8th grade class at Kent Middle School. That's a really big school. To give you an idea, I think the 7th grade class at Willard has a little less than 250 students, so this school is like 3 times as big as Willard. All right, so they want us to make a comparison. They want us to make a comparison between the two classes, between the 7th grade class and the 8th grade class. And this is the same thing as making the comparisons that we made in the 2 questions that we finished up yesterday between how many bracelets that Emily made and how many bracelets that Anna made. And the main thing you were supposed to see from these 2 questions that we finished yesterday was that anytime you make a comparison between 2 quantities, you can make that comparison in 2 directions. So first we compared how many Emily made to how many Anna made. And so that was a comparison of 22 to 32. Or in other words, we wanted to know what percent is 22 30-seconds. And that came out to 68.75%. Or in other words, Emily only made 68.75% the bracelets that Anna made. But you can make that same comparison the other way, just flip them around. What if we wanted to know, like, how many did Anna make in comparison to Emily? And so that's just reversing the division. We just do the 32 divided by the 22 instead, and that came out to 145%. So it's the same comparison, but now we're looking at how many Anna made versus how many Emily made, which is opposite of here. Here it was how many Emily made in comparison to how many Anna made. And so coming back to the question we're actually on, we have to be careful about which direction we make this comparison. We know we're trying to compare 750 and 625, but do we want to compare 750 compared to 625, or do we want to do 625 compared to 750? Well, for me, the easiest way to come up with the answer to that is looking for the word of in the question. I read here, it says, what percent is the 7th grade class of the 8th grade class? The quantity that comes after the word of is the thing that you should treat as the one whole unit, right? That's the thing that we're making. We want this as a percent of that, right? And so the word of there has a really strong implication about the thing that I say next is the whole unit. And so in that case, that means the 8th grade class in this case is the whole, or the comparison unit, and that's the 625. And then the part will be what we're what we are comparing to 625, which would be the 750 in the 7th grade. I could have written part here equals 750, but I decided to use the word quantity instead because sometimes it's weird to use the word part when the part is bigger than the whole. And so sometimes we prefer the word quantity there, but they really mean the same thing in this context. And so we have a whole, we have the quantity, and we want to know the percent, which is going to be x. So this is one way you could do this question. I want to show you how you could do another one, use the other strategy on this question, but how it could really mess you up if you're not careful. So I started to write this, and then I realized I was making such a bad mistake that I actually had to pause and start the video over and rethink about it, and that's why some of this work is already done here. So I'll explain to you what happened to me. I was reading the question, and I was trying to translate it into an algebraic equation like I've tried before, where I go, okay, what percent, so that's the thing I don't know, so I put the x there, and then I saw the word is, and so I put an equal sign, and then it says the 7th grade class, and so that's the 750, and then it says of the 8th grade class, and so I was going to write times 625, because of means times, and the 8th grade class is 625. And so I was going to write this, but I stopped myself before I even wrote it, because I was like, there's no way that makes sense. There's no way that x, the percent in this case, is going to equal 750 times 625. So I had to like stop and think for a second why my method wasn't working with this sentence. And I realized it had something to do with the way I was reading the sentence. It was like a weird English languagey thing that was messing me up. It says what percent is the 7th grade class of the 8th grade class, but it's just written in a way that's different than how we're used to. What it's really trying to say is, what percent of the 8th grade class is the 7th grade class? It's just written in a different sentence structure that made it to where it didn't work with my usual way of writing algebraic equations. It almost made me make a big mistake. So I'm going to rewrite this question here just in a way that works with my method better. So instead of what percent is the 7th grade class of the 8th grade class, I'm going to write what percent of the 8th grade class, I'll abbreviate that as GC, is the 7th grade class. And so now, even though the sentence says the exact same thing as this sentence here, just like in a different sentence structure, now I can more easily translate it to an algebraic equation. So this says what percent, so I'm even gonna get rid of this whole thing and just start over. What percent of, so that's an unknown thing, and then of means times, the 8th grade class, which is the 625, is, that's where I put an equal sign, the 7th grade class, and that's the 750. And so to solve this, I would just divide both sides by 625, and I get x is going to equal 750, over 625. You didn't have to do all that though. I just wanted to show you that way of solving it. You might be getting good enough now where you realize, oh, if I have a whole unit and a quantity or a part that I want to make a comparison with, then I don't have to do all this algebra stuff. I can just go back to these equations that I have here, and it says if you have the part or the quantity and the whole, you just divide them to get the percent. And that's what I wound up doing anyway, right? When I did all this algebra, in the end, I'm really just doing the quantity or the part divided by the whole. And so let's just do that and get it over with. We got 750 divided by 625 equals 1.2. And now the book is going to test to see if you're going to make a mistake here, because this equals 1.2. Oops, I wrote 1.20 just because I knew what I was going to do next. It says 1.2, but I wrote 1.20. And I did that because I know that in order to transform this into a percent, I need to move this decimal point over 2 spots, and that's going to be 120%. A mistake that a student might make is see that 1.2 and think that it's 102%, or maybe even mess up and only write it as 12%. I don't know. But I think the book was anticipating that students might make a mistake with that, because the next question says, the principal will have to increase the number of 8th grade teachers next year if the 7th grade enrollment exceeds, that means like goes over or is more, than 110% of the current 8th grade enrollment. Will she need to increase the number of teachers? And I would say yes, because the 7th grade is 120% of the 8th grade. But if you had converted this decimal wrong and said 102% or 12% or something like that, then you would answer no to question B, when the answer is actually yes, she will need more teachers. All right, let's move on. It says here, at Kent Middle School, there are 104 students in the band and 80 students in the choir. What percent of the number of students in the choir is the number of students in the band? So I'm looking for the words of here. What percent of the number of students in the choir? That tells me that choir is going to be the whole unit in this case, because that's the thing that we're taking a percent of, or that's the thing that we're making the comparison to. So I'm going to write over here that the whole is the number of students in the choir, which is 80, and that the quantity or part, whichever one you like, quantity, I'll write it like this, quantity / part, that's going to be the thing that we're comparing to the number of students in the choir, and that's going to be the 104 students in the band. And our job is to find the percent. And so this is another case where the number that we're comparing to the whole, which we always refer to as the quantity or the part, is bigger than the whole itself. And so that means we should come out with a percent that is bigger than 100%. So I want you to get an answer to this one, divide it out on your calculator or whatever, convert it to a percent, pause the video while you do that, and then check your answer in a second against mine. So you're pausing now. Okay, you should have paused the video and you should have an answer to number 2. And we could go through all the fancy algebra stuff, but we really don't need to. Really, if you need a percent, that's just part or quantity divided by whole. And so we're going to do the 104 divided by 80. Grab the old handy dandy, 104 divided by 80. It's going to be 1.3. Which, because I know I need to move this decimal point over 2 spots, let me write this as 1.30. And then I go 1, 2, and that's 130%. All right, let's move on. Oh, you know what? Really, I'm being kind of lazy. If you're asked a question in words, you're supposed to answer it in words. So if I was being a thorough teacher, I would say we need to write the number of students in band is 130% of the students in choir. All right, now let's move on. It says at Kent Middle School, breakfast costs $1.25 and lunch costs $3.75. Right off the bat, I noticed that this is 3 times as much. 3 times 1.25 equals 3.75. So that's probably going to play a role here. Okay, what percent of the cost of lunch is the cost of breakfast? Okay, so when I read that, I'm really conscious about the word of, because whatever comes after the word of is the thing that I'm making a comparison against, right? That I want a percent of that thing. So I want a percent of the cost of lunch. That means that lunch will be the whole unit in this case, which is $3.75. And I want to compare the cost of breakfast to that. So the breakfast will be my part or my quantity that I'm comparing to. And that will be $1.25. And so this is essentially the same as what we just did. We want to find the percent in this case. I hope you're getting pretty good at this by this point, that you see that, if I have a whole unit and some part or quantity I want to compare to it, I just take the part or quantity and I divide it by the whole unit. And I get a fraction or a decimal. So I know that since 375 is 3 times bigger than 125, when I do 125 divided by 375, I get 1/3. I only know that because this is 3 times bigger than that. Okay, well, and then I also just have memorized that 1/3 equals 0.3 repeating as a decimal. That's something that I encourage you to memorize. Math is not all about memorizing facts, but this one comes up so much that it's good to just have it off the top of your head. And so 0.3 repeating, that's like, you got 0.3, 3, 3, et cetera, et cetera. And so if I move the decimal point over 2 spaces, 1, 2, I get 33.3 repeating percent. Those 3's still go on forever after the decimal point. And so if we want to be super thorough and do our job completely, we would say the cost of breakfast is 33.3% of the cost of lunch. All right, let's do one more. I think this is the last question in the lesson anyway. Yep. All right. So it says, describe a real world situation that could be modeled using the equation 398.4 equals 0.83 times some unknown number x. And in my mind, I'm keeping track of the fact that 0.83 is the same thing as 83%. So some real world situation where you would need to know something about 83%. Describe how the elements of the equation correspond with the real world quantities in your problem, and then solve your problem. Okay, so this equation would be used if you know that 398.4 is 83% of some unknown number. So this is a case where you have the part or the quantity 398.4, and you know that the percent is 83%, and you're trying to figure out what the whole would be in this case, or maybe like some original number, something that you started with. Well, all right, how about this? Let's say Earth is like this big, and then there's some other planet that's a little bit bigger. It's kind of a lot bigger, actually. I didn't mean to make it that much bigger, but whatever. So we're going to call this Earth, and let's call this planet Marklar. And well, since Marklar is bigger than Earth, then however much you weigh on Earth, you're going to weigh more than that on Marklar, because Marklar is bigger, therefore it has more gravity, so you weigh more there. Okay, so maybe the rule is your Earth weight, not just yours, but anything, right? Anything, however much anything weighs on Earth is 83% of what it would be on Marklar. Okay, and then maybe you make a rocket ship or something, right? You're gonna blast off and go to Marklar. I have no idea how to draw a rocket ship. I don't know, flames coming out the bottom or whatever. So this is your rocket ship. And it's the lightest rocket ship in the history of rocket ships because it only weighs 398.4 pounds. And you need to figure out how much it's going to weigh after you land on Marklar, because that affects how much fuel you need in it in order to blast off of Marklar and come back to Earth. And so you need to figure out if your rocket ship weighs 398.4 pounds on Marklar, and that's, on Earth, and that's 83% of what it will weigh on Marklar. What will it weigh on Marklar? And so in order to, Marklar, so we need to divide both sides by 0.83 in order to solve this. And when you divide a number by a decimal that's smaller than 1, it actually makes the quotient, the number that you get at the end, to be bigger than the number you started with. So when I do 398.4 divided by 0.83, I expect a number bigger than 398.4. I'm expecting maybe 450 or so would be my guess. So let's see here. 398.4 divided by 0.83 equals 480. So your rocket ship is going to weigh 480 pounds when you get to Marklar. So you're going to need a little more fuel to blast off from there than you would from Earth. All right, that's the end of lesson 3. What I'd like you to do is I attached this exit ticket to today's activity announcement thing. Do this exit ticket, and then I'll show you the answers tomorrow. This is one of my favorite exit tickets from this whole book, and it sort of is a good representation of the type of question I would expect to see on a quiz or a test about this stuff. So you want to be able to do these two questions here. All right.